Hey guys, welcome to Geometric Sequence and Series Word Problems. These ones might drive you a little crazy, at least they do me, and that's only because of our n values. So we'll talk about that. I've got 4 examples to do, and since you can't quite see the whole thing, I'll read it to you. Austin earns $25,000 in the first year of his career. Each year he earns a 4% raise. How much will he earn in the first 10 years of his career? So first thing we have to do is decide if we're dealing with a sequence or a series. So if we're interested in how much he'll earn in the first 10 years, well, we need to take what he earns in the first year, right? Add it to the set, what he earns in the second, plus the third. So we're going to see how much money he earns as a sum, right? So I personally can't do these without this. Like this, I have to set this up. I don't have to fill them all in or anything. So we've got year 1, right, plus year 2, and then we're going to go all the way to year. Now, on my completed notes, I've actually got blanks all the way until year 10. So I'm just going to do this, just do a dot, 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 and then do a year 10 here. But you can see I've got everything filled in on the completed notes. So he earns $25,000 the first year. So a little bit different now, because now we have to figure out, okay, if he gets a 4% raise, he's not just earning that 4%, right? Because it's going to be on top of the 25,000. So you can calculate 4%. So if I type in 25,000 times 0.04, he'll get an extra $1,000. So of course, $1,000 on top, right? And when we're dealing with geometric, how do we calculate the R value? Well, we take this divided by that, right? So if you take 26,000 divided by 25,000, we're going to get 1.04. And 1 kind of represents including what was there before. So A value is 25,000, R is 1.04, and N is 10 years, right? We have 10 years, and so we're interested in the sum. So the sum of what he earns in 10 years is $25,000, and I'm pretty sure postage. Oh no, I didn't quite do that yet. Never mind. Sorry, I have to figure out what the formulas are. 1.0. Oh, you can't even see this. Oh, sorry. There we go. This is something you've seen before. So what I would probably recommend doing is calculating the numerator and then the denominator separately. You don't need my help for that. Seems like he's making a lot of money, doesn't it? And then, of course, word problems, we need a sentence. He will earn $300,152 in 10 years. Okay, that's 1 of 4. Just slide this over a little bit here. Hold on. That's a little bit better. Okay, second one. The color of some clothing fades over time when washed. Suppose a pair of jeans fades by 5% with each wash. What percent of the color remains after 10 washes? And where is it here? There's a picture of my jeans. There we go. So this is where it's going to get a little tricky. So I'm just going to line this up here. So sometimes, and I have to admit this took me a while to figure out, 10 washes you think, well, N is 10. Well, unfortunately, N is not 10, because what happens is, now we're not going to add anything, right? This is going to be a sequence. I'm just going to do this. So we have now, right? Because when they're brand new, obviously there's no fading. It's after 1 wash. So this is going to be after 1, and same deal, like my notes are a little bit more detailed than this because I don't want to write it out that many times. So if I have a now, and then I have an after 1 wash, after 2 wash, etc., what's my N value going to be? My N value is going to be 11. So you really have to watch out with these geometric ones, because sometimes you just have to figure out if there's I always say if there's a now. That's what you need to determine. So we're going to start at 100, right? So if it loses 5% after 1 wash, it's going to be at 95. Okay, what's it going to be after 2 washes? It's going to be at 90.25. We don't have to go quite that far, but just to kind of give you an idea. And how do we determine our R value? right? Well, we take this divided by this, which should be the same as this divided by this. So since we're not going to add these percentages, right? They're just decreasing. We want to know how faded they're going to be. So we need our T of n formula. A starts out as 100, R when we calculate it, 0.95, and N is 11. So if you're kind of working through these problems and you find that your answers are a little off, chances are it's the N value. So just as a heads up on that one, so T of n equals AR to the n minus 1, so we're dealing with the 11th. Just slide it over a bit more. And it says, oh, it doesn't say, but I just have it with 2 decimal places. So after 10 washes, the color remains. So faded jeans are in, that's pretty good. Okay, we got 2 more. Oh, this is going to be a long one to read, but that's all right. A truck transports 600 kilograms of vegetables to the market on Monday. From Monday to Saturday, the amount of vegetables the truck transport is increases by 15% per day. To the nearest kilogram, what is the total amount of vegetables the truck transports? So again, total amount, are we going to add them? Yes or no? Yes, we are. So we're going to go with Monday, right, plus Tuesday, plus Wednesday, etc., etc. Okay? So this will be Monday, Tuesday. Now we're only going to go to Saturday, right? No work on Sundays. So we've got 6, right? So we're going to add them together. A is 600. Oh, shoot. Oh, what I should have done instead of just doing that is I'll do that. So 600, when we add 15%, we get that. So you can just, if you know how to get from there to there, great. And if not, calculate 15% of that added on. Slide over just a little bit here so you can see that. And so this is 1.15 and N is 6. And so then we've got our sum formula again. And I'm skipping writing the formula, but that's there. 1.15. So I'll give you a second step here. So I worked out the numerator separately here. And hopefully you're able to recognize if it's a reasonable answer, right? The truck transports it says nearest kilograms, so I'm just going to go 5252 kilograms of vegetables. There we go. And the last one for this, and then I think we're just down to one more lesson. Bryden invests $2,000 on January 1st, 2020. His investments earn 3.5% at the end of each year. If he leaves the money until January 1st, 2040, how much will his investment be worth? And so this is another one where, of course, you can tell that we're dealing with lots of years. But remember, he won't earn any money until the end of the first year. So, and this isn't the sum, right? So we have a now. And then how I set this one up was January 1st, 2021. And then January 1st, 2022, et cetera, et cetera, et cetera, right? So now it's 2,000. If he earns 3.5% at the end of 1 year, he'll have earned $70 for doing absolutely nothing. Seems like a pretty good deal. Depends on what the market's doing, of course, right? So we're not dealing with the sum, we're dealing with T of n, right? So T of n, first term is 2,000. R is 1.035. And by now you should be able to figure out the pattern, what happens to the R value with the percentage that you're dealing with. So what's N going to be? Well, 40 minus 20, that's 20, but don't forget we have this too, so n is going to be 21. So T of n equals AR to the n minus 1. Minus 1, 3979. It's almost doubling his money for sitting there for 20 years and doing absolutely nothing. So Bryden's investment will be worth 397958. And there we go.